All right, stats, welcome to your spring 2020 final exam review video. I believe this is number 3. Anyway, we're picking it up for number 30 here on the review guide that I emailed to you 2 weeks ago. Quality control engineer would like to estimate mu, the mean life of battery made by the firm, random sample of 27, which is definitely less than 30, t distribution time, yielded a sample mean of that and a standard deviation of that. Make a 90% confidence interval for mu, the true mean. The mean, a sample mean plus or minus t star. Degrees of freedom would be 26. Go to your t table, degrees of freedom 26, 90% confidence interval. Remember, it's always just a little bit, or sometimes a lot more, than what the z distribution would give you. So 90% confidence interval using z star would be 1.645. This is a little bit bigger than that. Okay, 4.7 divided by the square root of actual n, 27. There you go. 95% confidence interval for Z, it's 1.96, so it makes sense it's a little bit bigger here. 2.056, please know how to read that. There is your confidence interval. All right. A certain well-known test has scores that approximate a normal distribution, Z time. The scores have a mean of 1030 and a standard deviation of 207. Find the score that would correspond to the top 10 percentile, top 10%. If you're in the top 10%, that means you're in the 90th percentile. 90% of scores would be your score or worse. So you need to go to your Z table, find what Z-score has an area of 0.9000 or closest to it. That is 1.28. 1.28 is equal to x minus 1030 over 207. Do a little cross multiplying. There we go. Top 1%, so you'd be in the 99th percentile. That's 2.33. There we go. Ooh, bottom 25%, so that area would be 0.2500. And I believe it's that one, negative 0.67. I actually did not. I'm pretty positive it's that one. So if I'm wrong, please let me know. What percent of students will score between an 800 and a 1200 on the test? Probability statement Z is, or X is your SAT score. This is an SAT, the old one. You had a normal distribution, or approximating normal distribution with roughly that mean and standard deviation. So let's just call it the SAT. First Z for the above average score. First Z score there. Area associated with it, and second one for the below average score, and subtract. So roughly 2/3 of students would get between an 800 and a 1200. All right, that page is done. Moving on to the next one, 32. 6% of components in your company sales will fail. Anyway, you guys can read. 1 business receives in is 250. Find the probability that 10 or fewer will fail within 10 months. X is a failed component. The mean would be 250 times 0.06, the normal approximation. Standard deviation is n times p times 1 minus p, the square root of that. You want to know the probability that x is less than or equal to 10. Right? Oh, shoot. We've got a mistake here. Okay. And always interesting. 10 or fewer. And that makes sense. Why would you have? Yep. Okay. And there could be, yep. Got another mistake here. Oh, sweet. Always great to catch them here. Well, folks, the formula, in case, like your teacher, you forgot here, is x minus the mean over the standard deviation. X is 10 here. The mean is 15. The standard deviation is 3.75. So that will give you a z-score of negative 1.33. And if you look that up, that should have an area of 0.918. That should be your answer. Now, let's try to correct this one. What's the probability 20 more of these components will fail within 3 months? 20 is your x. 15 was is your mean. So that is going to be 5 over 3.75. And we're lucky here. We know from the previous one that it's 1.33. Z-score of 1.33 will give you an area of 9082. I can see from the previous one. But you want the area to the right of that, so you're going to do 1 minus 9082. All right, to get the same answer as A, 0918. Okay, that was interesting. Find the mean and the standard deviation of X, the number of components that fail within 3 months. We did that at the very beginning, 15 and 3.75. Next one is the Poisson distribution that we do. You're not given a standard deviation, no probabilities you're given. You're just given an average number of malfunctions in a certain time interval, which is a day. Poisson distribution. E, Euler's constant, 2.71 ... to the negative mu times mu to the x over x factorial. Okay? You guys definitely try. If you have the scientific calculator, my gosh, you're going to be okay. If not, you have 2 weeks to get one on your iPhone there. Certain days sees 3 or 4 major malfunctions. Probability x is 3 plus probability x is 4. Yes, always write a probability statement. E to the negative 3.2, because that's the mean. 3.2 to the third, because that's x over 3 factorial, which is just 3 times 2 times 1. It's just 6. Plus e to the negative 3.2. 3.2 to the fourth, that's x over x, which is 4 factorial. Take your time. There you go. Certain day sees 2 or fewer, so probability x is 0, 1, or 2. All right, there you go. We already know the probability of getting 2 failed. Oh, no, we do not. We do not know the probability of getting 2 failures. We got to do all that. There we go. 34. I want a 95% confidence interval for the true population proportion. This is simple polling here. Okay, p hat is that. 95% CI, 1.96 times the square root of p hat, 1 minus p hat divided by n. Okay, it did not ask you to interpret it, though. Notice that it does go below 50%, so people in favor of this proposition should not get too cocky, because there's a chance it could fall below on the real important day of the voting. A certain regional grocery store wishes to average 200,000 a week. 80 of its 119 stores, only 80 in is 80. So that is greater than 30. Greater than or equal to 30, we can use Z there. Sample mean plus or minus C star times the sample standard deviation divided by the square root of n. Do round to the nearest penny, we're talking about money. It didn't say to interpret it, but notice that on the high end, they're still under 200,000. So their wish for averaging that is not looking great. Now we start to test, folks. So you guys can read 36. I will highlight that sample of 60. We can use Z. At least means greater than or equal to. Equality, anything with an equality part is always the null hypothesis. Greater than or equal to would have an opposite statement of less than. Notice it did fall short in testing, so it makes sense we would do a left tail test. 5%, if alpha is 5%, that means 5% to the left. Well, 5% would be over here. 90% confidence interval number, that's negative 1.645. Again, you'll have this in your notes at disposal, so it shouldn't be hard to remember. That's how we find our test statistic. We definitely reject the null hypothesis, and we say that the alternative hypothesis, a mean of less than 36, is correct, is looking good. 37, this is one involving a proportion. They say more than is clearly greater than 0.75. The null hypothesis is less than or equal to. This is maybe not the best one I've written because it tested very high. We got a insane. So first off, 1%, one tail is 2.33. Right tail test. We get an pretty large. We've seen larger z-scores, but 8.88, it did so well that we can definitely reject the null hypothesis and say yes, 75% or more than 75% of patients have a certain symptom cured with this. Again, pause this whenever you need to. I made a big boo-boo on 38. I did 2 different confidence intervals. It clearly says create a confidence interval for the difference in the mean scores. That is x bar 1 minus x bar 2 plus or minus, in this case, t star, sample of 28. Then a sample of 23. So whatever the lowest sample size is, you use that. So degrees of freedom would be 22. Degrees of freedom 22, 95% confidence interval. That was my t star. And then it is your sample standard deviation for the first one squared divided by its sample size plus sample standard deviation of the second one squared divided by its sample size. Okay, and it just wanted you to create. You don't have to interpret at all, but it didn't cross 0, so there would be a true difference in the mean scores. So math majors do have a higher entrance exam, okay? If it asks for a 95% confidence interval for the difference in the mean scores, that is a single confidence interval. That's not 2 separate ones. 39, we are testing. Okay, now, yes, they have 578. They didn't test them all. They tested 191 of them. So p hat is 44 divided by 191. Notice more than 20% would be greater than 0.200. This is a right tail test, which makes sense because our sample proportion there, our p hat, is greater than 20%. So it makes sense to do a right tail test. Alpha is 0.05, single tail to the right would be 1.645. Our z star, or, which begins our rejection region. Our z score to begin the rejection region. Z is p hat minus proposed p divided by, in the square root, is the proposed p times 1 minus the proposed p divided by the sample size. It is not in the rejection region, so we do fail to reject it. Even though they tested above 20%, we do fail to reject it. It was not a statistically significant result. 40, university has found that over the years, about 67.4% actually accept an offer of admission. We've done this one before. P hat, looking pretty good. Is this evidence of an increase? So greater than the old status quo. Right-tailed test. Alpha is 0.01, single tail 2.33. There is Z. Huge. You definitely reject the null hypothesis. Okay? That Z score does need to be correct. So please don't do any rounding, all right? That Z score does need to be very, very close to that. All right, folks, next page. 41. Energy Bar Company claims it's exactly 80. 50 were tested, so allow you to use Z. Okay, exactly 80 equals 80, does not equal 80. That is a two-tailed test. So 95% confidence interval. If alpha is 0.05, your test statistic, negative 5.20. You definitely reject HO, the null hypothesis. The mean is not 80. Now, I've gotten rid of this 42. You can too. I don't think we talked about these a ton. That was going to be in the later part of March, early part of April, so you can get rid of 42. 43, create and interpret a 95% confidence interval for the difference. 28, 42. 42 is greater than or equal to 30, but 28 is not. That's T distribution, degrees of freedom 27, 99% confidence interval. That is your T star. X bar 1 minus X bar 2. That is your confidence interval. It does not cross 0. So a true difference in the means exists. That means the new process is definitely decreasing malfunctions. All right. I like to try to keep going here. I want to do 44 and 45 on this next page. At most is less than or equal to 0.025 is 2.5%. 14 out of 400 would give you a p-hat of 0.035. Right-tailed test. At most is less than or equal to. The opposite of that is greater than. Right-tailed alpha is 0.05. Means that's 1.645 begins your rejection region. There is your test statistic, 1.28. Not in the rejection region. You fail to reject the null hypothesis and say that their claim is technically true. Or you can't say that their claim is incorrect. How about that? That's much better. 99% confidence interval for the difference. You need to add that the second one is the non-smokers. It's not smokers and then smokers. The second one is the non-smokers. Wrinkles, prominent wrinkles for the smokers. There's your P1 hat. Prominent wrinkles for your non-smokers. There is your P2 hat. Okay, anytime we're doing proportions, always Z star, 99% confidence interval. That is the 2.576 Z star. Okay. Again, you guys have those formulas. Here is your answer. Does not cross zero. There's definitely a true difference in population proportion. Folks that smoke are going to have an increased chance of getting those prominent wrinkles. All right, next page here, 47, distribution of adult